Great orthogonality theorem is made to define the irreducible representation. In simple way, how can we understand irreducible representations? That we are studying in this part. Total 5 conditions are there, 5 rules are there, 5 properties are there, 5 characteristics are there, those to be fulfilled by irreducible representation. Which are those? The first, total number of irreducible representation means gamma i's is equal to total number of classes. If I consider water as an example, in water, how many classes are there? Identity, C2, sigma, sigma dash, 4 classes are there. So 4 irreducible representations will be there for water, gamma 1, gamma 2, gamma 3, gamma 4. If I consider C3V as a point group, how many classes are there? 3. So gamma 1, gamma 2, gamma 3. If I consider D2H as a point group, D2H is one of the abelian group and there 8 operations are there. 8 classes will be there. Gamma 1, gamma 2, gamma 3, gamma 4 up to gamma 8. 8 will be there for D2H point group. That is our first rule or first property or first characteristic. Now second characteristic, if I consider the members present in the same class, then the members of the same class will be with same character, and that we have studied in C3V point group. Character for C31 and C32 was same. Let you consider reducible representation or irreducible representation. This property is applicable in C3 point group. Characters for all those 3 planes same and all those 3 were belonging to same class. That's our rule. Members present in the same class have same character. Is that second rule clear? Now third rule is related to dimension. What is dimension? Dimension is a character or trace of identity. So identity is the operation. If I consider different irreducible representation, then character below identity for different irreducible representation. Summation of squares of characters of identity or summation of squares of dimensions is equal to H. What is H? H is the order of the point group. That is our third characteristics. Summation of squares of characters for particular irreducible representation is equal to H. How can I represent it mathematically? Summation of character means chi, ith irreducible representation therefore I in bracket R and its square, where R is a variable, is equal to H. What is H? H is the order of the point group. It is our fourth rule or fourth property or fourth characteristics for irreducible representation. Now the fifth rule and the important rule which decides about orthogonality. Here summation of multiplications of characters of various operations is equal to 0. How can I represent it mathematically? Summation of chi I R means character for operation R related to ith irreducible representation into chi J R means character for operation R related to jth irreducible representation. Their multiplication and summations is equal to 0. These 5 rules if are fulfilled, then that character table will be with all irreducible representations. While constructing character tables, these rules are going to help us. It is a very important aspect of the molecular symmetry and group theory. Therefore, separate video on this is prepared because these rules we are applying and are going to construct various character table. In your syllabus 3 character tables are there. One C2V, second C3V and third D2H. Those we are going to discuss one by one. Are these 5 rules clear? Let us recap fastly. Total number of irreducible representations gamma i's is equal to number of classes. Second, members present in the same class have same character. Third, summation of squares of dimensions is equal to H. Fourth, summation of squares of characters for particular irreducible representation is equal to H. And fifth, summation of multiplication of the characters for different irreducible representation is equal to 0. If these rules are clear to you, you can construct the character table. Representation in the words and formulae. Total number of irreducible representations is equal to number of classes in the group. It's our first rule. Second rule, characters of operations belonging to same class are same for ith irreducible representation. Rule number 3, summation of squares of dimensions of all irreducible representations is equal to H. Summation of Li square is equal to H, where I is a variable, I is a irreducible representation. Fourth rule, summation of squares of characteristics of all operations in particular irreducible representation is equal to h. Summation of chi I r square is equal to h, where r means operation, is variable. For all different operations for one irreducible representation, we are applying this rule. Fifth rule, summation of multiplication of characters of respective operation from two irreducible representations is equal to 0. Mathematically, summation of chi I r into chi j r is equal to 0, where r means operation is a variable. This rule decides the orthogonality of irreducible representations. As a homework question for you, if we consider representation of dimension 1, then what do you think? That representation is always irreducible. Is it true? If true, write yes. If no, then say no in comment box. I am waiting for your answer.